Hello all. In this lecture, we will see about functions in Python. So we have seen several inbuilt functions of Python in the previous lectures. So we have used many mathematical functions of Python. So in this lecture, we will see about user-defined functions in Python. So we will define a function like it is a block of organized, reusable code that is used to perform a single related action. So it's a block of reusable code. That is, function itself is a code which can be reused and it is used to perform a single related action. So this code is used to perform a particular action. So if, for example, if you want to find sum of two numbers, so you can write a code separately and this code can be reused. That means this code can be used for some other application also or some other program. You can simply copy and paste that code there. So it is a block of reorganized, reusable code that is used to perform a single related action. So functions provide better modularity for your application. Modularity means if you divide the whole application into different modules, it will give much more easier to understand for the programmer. So we can separate it into different modules. And when you want to maintain that code, it will be much more easier for the programmer. And also there's high degree of code reuse. That is, we can reuse this code. If you are writing a particular code for a particular program, you can reuse that code and use it some other application. Functions are not necessary in Python. You can write it in a single program itself. All the things can be written in a single program without using a function. But the problem, if you are not using this function, then it will be very difficult to verify. So if you want to find out some errors, if some errors occurs, it will be very difficult to find out. Or if you want to change something, if you want to maintain that something, if you want to maintain a particular code, if you are dividing it into different functions, you have to change only a particular function. Otherwise, if you are not using these functions, you have to change the whole program. So if there is no function, it will be impossible to maintain the code. Another thing to note is humans can remember only up to 3 to 7 things at a time. So it will be very difficult if you are writing a whole program or the whole thing in a single program. Will be if you are writing simple programs. If you are writing a very big large applications like bill management system or a supermarket bill software, if you are dividing it into different functions, it will be easier to find out some errors, or if you want to correct it, or if you want to change something, it will be easier if you are writing it into separate modules or separate functions, because humans can remember only up to 3 to 7 things. So if you are dividing the whole code into up to 3 to 7 different functions, it will be very difficult, very easier to write those programs. And another thing is that function provides an abstraction. So abstraction means hiding inner details, inner things. So if you are writing a code to find the sum between a range of numbers, the inner code will be hidden from the user or the programmer. You can simply call that function and execute that code. So it's a way of hiding the inner details. For example, I'll say a real life example. So if you are saying that make a cup of coffee, so make a cup of coffee has several different internal things that will be happening. You have to take cup of water, you have to boil it, you have to take milk, you have to boil that milk, you have to add coffee powder, you have to add sugar. All those things have to be done. So all those things are internal things. You are abstracting those internal things by just mentioning that make a cup of coffee. So make a cup of coffee is a kind of abstraction. Similarly, functions can also hide the internal things and show only what is needed. So use of functions. So we will see this example first. So this is a function. Def, we will see the syntax and all later. So def sum. lower to upper. So this function actually what it does is it finds the sum of numbers within a range. So if you give lower as 1 and upper as 50, it will find the sum between 1 to 50. So it will add 1 plus 2 plus up to 50 will be got, and that sum will be returned. So this is the sum between lower and upper function. So what happens is this function eliminates redundancy. That is, if we want to find the range of a between two numbers in several parts of the program, if we want to do at one part of the program, if we want to find the sum between 1 and 50, then in another part of the program, if you want to find sum between 100 and 150, if you are not using this function, you have to write the same code, this code, while lower to upper, this same code repeatedly in those areas. But if you are using this function, you can simply write this, you can simply substitute this single line, sum of 1 comma 10 or 1 comma 50, or sum of 100 comma 150. Like that you can substitute. So it eliminates this redundancy or repetition of this code. We need not rewrite the code again and again. And also functions hide complexity. Previously, I have mentioned about abstraction. So the sum between this lower and upper contains several internal details. So if you see that, we can see there is a while loop here, then we are incrementing this lower, then we have to add this result. All those things are happening inside the code. But we hide this complexity by simply calling this function like sum 1 comma 10. So we'll get the result. So it hides the complexity of the program. Then another use of function is function supports general methods with systematic variations. So we can write a generalized function, and if you want, you can have some variations inside this function. So here, our function have only two arguments. We can add a third argument or third parameter. We can add a third parameter saying that I want to add only the odd numbers. So you have to add 1 plus 3 plus 5 plus 7. You have to skip 2, 4, 6 and 8. So if you add a third parameter mentioning that you have to skip one number, you can add those instance or add those third thing. So you can have variations of functions like adding several other arguments also. That is why we call it support general methods with systematic variations. Then functions support the division of labor. So if you are separating into different functions, the the whole program's task will be divided into different programs or different functions. So one task will be assigned to a particular function, another task will be assigned to another function. So it is easier to, if you are writing like that, will be easier to maintain that code. So we'll see the syntax of a function. So the syntax starts with df, then there will be a function name, and in parentheses there will be parameters. We will specify the parameters and colon. So this is a function header. Then we can have statement or several number of statements inside this function. Then finally there will be a return statement, and the expression is an option. We will see each and everything. So keyword def marks the start of function header. So this keyword def starts with the starting of a function. Then function name is this used to uniquely identify it. This function name is used to uniquely identify this function. You can we have already seen the identify, how to define and identify, how to write, how to use this naming convention in identify. Similar conventions can be used for Python function name also. Then parameters, or we call it as arguments also, through which these parameters through which we pass values to a function, and this is optional. So this is optional. We can have several parameters through which we pass the values to the function. So if you want to pass some values from the main program to this function, we can supply using this parameters or arguments. Then after that, a colon will be there to mark the end of function header. So this colon will mark the end of this function header. So this first line is the function header. Then after that, one or more valid Python statements that make up to the of the function body and must have same indentation level. So we can have several different statements inside this, but all those statements should be at the same intent. Then finally, there will be an optional return statement to return a value from the function. And there will be a return statement. This is not necessary. This is an optional return statement and optional expression will be there. We will see all those return statement later. So this way we can define a function. We will see an example. So this is an example for a print function. Def, and this is a function name. You can use any name. I have used print and capital function. In the inside this we have a parameter. This is str. There is a string parameter, and we can include this doc string also. We have already seen doc string, so this gives some comments what this function is and all those things can be with if it is three quotes, three double quotes, it means you can it is separated into different lines. So this is an optional doc string can be included inside a function. Then this function statement, we have only a single statement. So this statement is print statement. It prints str plus it will be concatenated with have a nice day. So whatever string that is applied to the function, if you are printing hi Anand, hi Anand, have a nice day will be the output. Then there is a return statement also. Parameters are optional. Return expression is optional. Return expression is optional. So we have a single return statement. So this is an example for function definition. This is the syntax. Okay. So if we see, it is all the same intent. Print and return are the same column. Then only otherwise it will be an error. Okay. And how to call a function. So we have written a function. So in the program, we need to call that function. So it can be executed by calling it from another function or directly from the Python prompt. So if we have this function, we can simply call it in the Python prompt itself, like this print function, and inside parenthesis you have to specify the argument. So here it is a string str parameter, so you have to specify a string inside this argument. Then what happens is it will go execute this and it will print that str, that a string will be printed and concatenated with have a nice day. So Anand will be printed concatenated with have a nice day. Then if you are giving this print function Arun, inside this string we are giving as Arun, then Arun have a nice day will be printed. So this is a way how to write a function and how to call a function. You can simply call the function using the Python prompt itself. Then we will see the return statement. So it's an optional statement. So it is used to exit a function and go back to the place from where it was called. So it is a kind of exit from the function. It will go back to the place from where it was called. So if we are calling from a particular program, it will go to the same step or the next statement which is to be executed. So when the function gets executed and when the function gets completed, if there is a return statement at the end, it will return to the place where it was called. So syntax of return. So it is return and there is an optional expression list. Okay. So expression. So if you are giving some expression in the return statement, then that expression gets evaluated and the value will be returned. So we will see that example also. So if there is an expression in the return, it gets evaluated and the value will be returned to the main function or the main program which it was called. So if no expression or the return statement itself is not present, if there is no expression and also if there is no return statement at all in the program, then function will return the none object. It will return the none object. It will automatically go to the program. So it will return the none object. So we'll see an example here. So this program, this function actually finds the absolute value. So if we give -5, it will return 5. If we give 5, it will give return 5. So it will find the absolute value of a particular number. So this is a function name absolute underscore value, and num is a parameter, and this is a doc string. This function returns absolute value. This is a doc string. This is optional. So if number greater than or equal to 0, then return num. That number itself will be returned. Else, if number is less than 0, less than or equal to 0, you can change it. You need not give number greater than or equal to 0. You simply mention number. Okay, it's correct. Okay, if number is less than 0, then it returns minus num. So this is an expression. Minus num is an expression. It has to evaluate what if you are giving -5, what you have to do? You have to take the minus of -5. It will be +5. So the +5 will be returned. So this way you can execute this code absolute underscore value of 2. If you give like this, this is the argument. You have to supply a number, then 2 will be the output. So if you are giving -9, then 9 will be the output. So if you call this function, what happens is it goes to the statement, it will execute, it will check whether number greater than or equal to 0. If it is greater than or equal to 0, then that number itself will be returned. So if you are giving 2, 2 will be returned and the execution stops. Then if you are giving if you are giving -9, then it will take the minus of -9. It will be +9. So 9 will be returned. Next, we will see scope of variables. So scope of a variable, it's a portion of a program where the variable is recognized. Scope of a variable means it's a portion of a program where a variable is recognized. So we'll be defining different variables inside the function, and we'll be using different variables in the main program also. So the scope of a variable specifies where that variable is recognized. So parameters and variables defined inside a function is not visible from outside. So whatever we define inside a function, it is not visible outside. So if you define a variable like x inside a function, that x won't be visible outside the function. So it is the visibility of that variable is within that function. So we cannot use that variable outside the function or get the value of that variable x outside the function. But we can use the same variable x, or you can define another variable called x in the main function also. So local scope, we say that variable is of local scope. If we are defining a particular variable inside a function, then we can say that it is of local scope. That is, it is limited to that function alone. So we will see an example for that. Then you will understand what we mean by the scope of a variable. So we have a function def, and change is the name of that function, and we have a parameter x. So inside this, we are assigning a value 5 to x. Then we are printing this value inside the function x, and there is a return statement. The outside this function, this is outside. These three lines are outside this function. So these are only these three statements are inside this function, and this is outside the function. We are defining the same variable. We are using the same variable x, and we are assigning 2 to that x. Then after that, we are calling this change x, change of x. So what it does, it goes inside this function. 5 is assigned to x. Then we are printing that value x. So here the function, this print function prints 5 here. Then after this return statement is executed, it will return to this statement. It will print again value outside the function is x will be printed. Here the x value will be 2 itself. 2 itself. We will run this program, you can find out. So value inside the function is 5 and value outside the function is 2. So even though we have changed the value inside this function, we have changed the value x value to 5 inside the function, it is not visible outside the function, because when we print this function, we can see the value 2 here, because the scope of this x is limited to this function only. So this is not acceptable. This x is another variable. This x and this x are not same. This is known as local scope. So the x value is limited to that function alone. Okay. The lifetime of a variable. So period throughout which the variable exists in the memory. Lifetime of a variable is known as the period throughout which the variable exists in the memory. How long that variable will exist in the memory. So if you are using uh, if you are using a variable inside a function, that variable gets destroyed as soon as it exits the function or the return statement executed. So lifetime of variables inside a function is as long as the function executes. So after the function completes its execution, that memory will be lost from the memory or removed from the memory. So it destroyed once the function is returned. When the return statement is executed, all the variables that are used in the function will not be accessible in the other parts of the program. So function does not remember the value of a variable from its previous calls. And if you are again calling the same the function repeatedly, those previous variables of the function won't be remembered. All those variables will be forgotten, even though we are calling the same function repeatedly. Okay. So same example, you can see that. So this is same example. So uh, you can call the change again and again. Okay. You can use the same code again and again, and you can print the same statement here also. I am simply incrementing this value. I will increment this x equal to x plus 1. Okay. So what is this function? We are initially assigning two value to x. Then you are calling this change function. So what happens is this function will be called here. 5 is assigned to x. Then you are simply incrementing this function, or I will give the statement here. You are simply incrementing this function. You are print x 5 is assigned to x, then you are printing this value x, 5 will be printed, then x is incremented to 6, then it will be returned to the main function, then this statement will be executed. Here the x value is not 6 because in this program the scope is lost, that visibility is lost. So x2 will be printed. Again you are calling this change function. So again it goes here, it won't, that previous value of x is 6 won't be remembered again. X will be assigned 5 and printed 5 value will be printed and 6 will be increment, it will be incremented to 6. You will run this program, so it will be look like this. So value inside the function is 5, then outside 2, again if you call again it will be 5 because it lost the previous value of 6. It has forgotten that value. Whenever that function returns to the main program, it lost that value. Okay. So that is the lifetime of a variable. We will see some examples of function. Okay, this is a program to illustrate this user-defined function. We have defined a function addition x comma y. This function simply adds two numbers. Whatever parameters we are passing, whatever arguments we are passing, those two numbers will be added and the sum will be returned. So in the main program, we are getting two numbers. Num1, it is converted into float, and num2, it is also converted to float. Then we are having a print statement in the main program. The sum is, and in the print statement itself, we are calling this function. Addition function is called, and two arguments are passed. Num1 and num2 are passed. So what it does is it calls this function, and num1 value will be assigned to x, and num2 value will be assigned to y. So if you are giving 12 and 24, x will be 12 and y will be 24. So inside this function, this is a doc string. This is simply a comment. Then here, sum equal to x plus y. So what it does is x plus y, x will be 12 and y will be 24. That addition will be done and it will be assigned to sum, and sum will be returned. So sum will be returned here, and sum will be, that value will be printed in this print statement. So if we execute this program, you will be asked to enter two numbers. I'm entering, you can enter floating point numbers also. The sum will be 46. Okay. So this sum can have expressions. This return statement can have expressions also. It's not necessary that you have to include like this. You can simply use this x plus y here. So this is an expression now, x plus y. So this way also you can execute this program. So if you give 12 and 34, 46 will be returned. So what we have done is we have used an expression instead of single variable. We have used an expression. So return statement can contain expressions also. Okay. Then we will see another example. It is to find the prime factors of a particular number. It's a program to find the factors of a number. So this is a function. We will see the main function. So what in the main function, we are getting an input number. We are asked to enter a number. It is converted into integer type. Then print underscore factors. It is a function. We call that function by supplying this argument, num argument. Whatever integer we have entered, that will be supplied here. So that will be assigned to x. So this is a doc string. After that, this print statement will be executed. The factors of x are. Then we are trying to find out the prime factors using this for loop. So for I in range 1 to x plus 1, what you have to do is you have to find whether remainder equal to 0. If that remainder equal to 0, that means that's a prime factor. So we have to print that I value. So if you run this program, you can enter any number 100. If you enter 100, these are the prime factors of that number. So every time that loop executes, you will get the prime factors one by one. So here we don't have a return statement. We don't have a return statement in this function. There is no return statement. So it simply executes that function and it returns none. So we have already mentioned that return statement is optional. So in this program, there is no return statement because we are not executing any line after this code. So it can be stopped there itself. So all those prime factors. So this is a simple program to find the prime factors. We have already seen how to find these prime factors. You have to simply check for the remainder. If that remainder equal to 0, that means that's a prime factor. We have to simply print that I. Okay. Then another example I'll show. So program to make a simple calculator. That is a program to make a simple calculator. You can add, subtract, multiply, and divide. Okay. So we will see the main program first. So this is the main part of the program. So we have to select, this will be printed first, select operation. All these things will be printed. One to add, two to subtract, all these things will be printed in the prompt. Then the user has to make a choice. We have to enter value 1, 2, 3, 4. And that value, we have to make a choice. One, whether we have to add, subtract, multiply, or divide. Then we have to get two numbers, num1 and num2. So if you want to add two numbers and all, we have to get those two numbers. This is the same and it will be converted to integer. You can use float also. We are doing only integer addition, subtraction, multiplication, division. Then if choice equal to 1, if the choice, if the user entered that choice as 1, then what you have to do, you have to call a sum function, you add function. We have to call this add function. So we are adding those two numbers, num1 plus num2. This is simply to print those two one equal to, these are all string concatenations. Num1 is a string, then integer, then plus is a string, then num2 is another integer, then this equal is a string. Then what it does is it calls a function add num1 comma num2. So we are passing two arguments. So if you are entering 2 and 4, those two arguments will be passed here and it will call this function. So def add comma x comma y. So 2x will be assigned to 2 will be assigned to x and 4 will be assigned to y. Then it will simply return x plus y. So here's this is an expression 2 plus 4. So that expression will be evaluated. 2 plus 4 it is 6 and the value 6 will be returned and 6 will be printed. So if your choice is 2, then you will call this subtract function. So subtract function will be called. This is a subtract function. Here x minus will be 1, y will be returned. So if you are calling this multiply function, this multiply function will be called and x into y will be done, or divide function is x by y will be done. So in this way you can do so we have four different functions to perform four different tasks. So we have four different modules. We can call it as five modules, main program, and four different sub functions. Okay. So this is all a simple calculator program. If any other input is entered, it will return invalid input. So you can run this program and see. So select operation, you can select any of these operations. So I am selecting 3. Then you have to enter first number and you have to enter second number. Then 23 into 45 equal to 1035 will be printed. Okay. So these are some of the examples, and this is a reference book, Fundamentals of Python by Kenneth Lampert. Thank you.